Hello everyone, welcome back to Data Programming 1. A couple of reminders as we get started. We have an exam this Wednesday. That's 2 days from the time that this lecture will be released on Monday. If you're not watching it till later, it's still on Wednesday. As you guys get started studying for that exam, I highly recommend that you check out the practice exams that are available on the website. Those are exams that have been given in this course in previous years. Make sure that you have a good understanding of all of the topics covered on those exams. We're going to be covering the same topics on this exam. The exam format should look very similar to the last couple of quizzes. We'll be using Canvas quizzes for the exam, and there'll be an email coming soon with the exact dates or times that the exam will be available. All right, there isn't a template to take notes on this for this lecture. It's mostly just the PowerPoint slides I'm going to be going through. We'll do some demonstrations at the end. The Jupyter notebook file that's there on the webpage is the completed version after I've gone through and done all of the demonstrations. You're welcome to download that one and take a look at it. Otherwise, if you want to take some notes, just open up a blank Jupyter notebook and take some notes there as we go through. All right, so today we're going to be talking about files. Let me advance to the next slide here. So first up, stuff we're already familiar with. We can use that information to already know a bunch of things about files if I tell you that file objects are a kind of iterator. Now, remember that an iterator is something we can call next on. So we already know something about file objects. It means we can call next on them and get more data out. All right, the next thing, we'll go back one lecture. We're going to see that exceptions occur a lot with files. So the example I've been using during most of last week's lecture, and the one we've seen a lot throughout the semester, is the divide by zero exception. If we're careful with writing our code, we can check, we can use a short-circuited if statement to just check and see if the denominator is zero, and we can get around that. It's almost impossible to check ahead of time with files if something's going to fail. For example, suppose we're just trying to create a file and save some stuff on our hard drive. All right. First up, the hard drive could run out of space, so that's dangerous. So you think the easy solution is, well, we just need to check and see if there's enough space on the hard drive before we create the file? The problem here is that our program isn't the only thing that's running on our computer. There are a bunch of other programs. Necessarily, there must be the operating system, like Windows. And because we're not the only program that's running something, another program can jump in after we check to see there's enough space. That other program can create a file and use up that space. And then when we try and save our file, that space is gone, there's no longer enough space, and it'll fail. It's just one of those things that are unpredictable. It's outside of the control of our current program that we're running. And there really isn't a way we can avoid that ahead of time. So instead, what we do with files is just wait for the exceptions to occur and deal with them when they arrive. So the plan for today is to look at a few things. First up, just basic file interaction, stuff like getting data in and out of files. Then we're going to learn about the OS module. This contains a bunch of stuff about directories, really useful for us, how to put together paths that will work on Windows or Mac. So it's portable code we're generating, just stuff to list the directory, stuff to see if something's a file, does it exist, that kind of stuff. Useful utility functions. Then we'll be talking about file exceptions, and remember these occur a lot, so it's just something we'll need to try and accept for to catch all of these problems when they happen with files. You should just think of them as necessary when working with files. And then we'll probably move a little bit into encodings and talk about how different text files are encoded into ones and zeros so the computer can understand them. So I've already hinted that we're going to be working with file objects. And we get file objects by calling the open function. Remember that everything in Python is an object, and this is just a built-in function, the open function, that we can call from anywhere. We don't need to import any sort of special module in order to open a file. This function takes the file path, and that somehow tells us where the file we want to open is. That parameter is going to be a string, and this open function is going to return a value. That value is the file object. So we're running the code here in main.py. This is in the demo directory. So if we want to open the file.txt, this one right here, there it is. All we need to do is give the open function a parameter. That's the file path as a string. This is an example of a relative path. They're both in the same directory. All I need to do is use the file name. I don't need to give it any more information, and Python can find it. It's in the same place as main.py. Now, if we copy main.py to another directory that also has a file named file.txt, a different file, it's going to open that other file.txt instead of this one. It's going to be relative to where main.py is, so in the same directory as where we run main.py. All right, another really common situation is that I'll have a data directory where I've got all the files I need to open. Let me click that. So we can see in here that I've got movies.csv. In order to open movies.csv, I need to give it the relative path to movies.csv. So if you remember back to actually lecture 2, when we talked about the terminal and the shell, we talked about directory structure. And so to open this, I need to give it the name of the directory I wish to open, followed by a separator. This is either going to be a / on Linux and Mac, like we have here, or a / on Windows, followed by the name of the file. All right, so this is actually using a relative path that's only going to work on a Mac. This is not portable code, and we'll talk about how to deal with this file separator when we get to that OS section, the operating system, in part 3 of the lecture. So also remember, this is still a relative path. It's relative to where we have main.py. And if I move main.py to another folder that also has a data directory, we won't be getting this movies.csv, we'll be getting another movies.csv if it exists. Okay, also these file paths may be many levels deep here. Inside of snapshots, I have file A, in which case I just keep adding another separator followed by the name of the file I want to read. Once we've opened the file and have that file object available to us, we're generally going to be doing one of two things with the file object. So first, reading data from a file means we're going to be pulling in data from a file and storing like maybe a string or some other data structure in a variable in Python. That way we can interact with it in Python. And then writing the file means we're going to be starting with some data in our Python program, and we're going to be storing that data in a file. That's going to let us use this data later. If I close my program or the computer powers down, that data will still be available and I can bring it back into my program when I restart it. Also, when we're finished with files, it's important to close them. To do that, we're just going to call the method f.close. Remember that objects can have methods associated with them, and we're going to use that dot notation to access the methods or functions associated with a particular data type. Now with files, usually we can get away without closing the file and just letting the program end without any trouble, but this is an important thing to remember because that's not always true. In rare cases, things can go wrong and then we lose our data if we don't close the file. We're not going to go into specifics here, but just be aware that this can happen. The other reason it's important to close your files when you're done using them is that your computer has a limited number of files that we're allowed to have open at any one time. So we should close them when we're done. So far, all of the examples we've done and all of the projects had maybe 1 or 2 files. I think we used 2 files with the movies.csv and the mappings.csv project, and that's it. But can you imagine downloading all the pages of Wikipedia? You know, if you want to do some analysis, there are millions of files, and you can easily hit that limit if you're not careful and don't remember to close files when you're finished. So what we're looking at here is an example of a protocol. So a protocol is just a set of rules that programmers have agreed to use when working with a particular structure, in this case files. So here it's a list of functions that we have to call in a certain order. That's a protocol. So to begin with, we have to call the open function in order to open the file, get our file object. Then part 2 of the protocol is we use the file. We either read to it or write to it. And finally, we have to close the file. So it's just a set of 3 conventions that we have to follow when working with files. It's not like a sandwich where we have the bread open, the bottom bread, the close, and in the middle, the guts of the sandwich, the good part, where we actually use the file. But we're required to open and close these as we work with files. All right, next we're going to move into the 2 things that we can do with files, and we're going to be starting with reading. First up, in my example here, in my main, or in my demo directory, I've got main. This is the program that's running. I have my file here. This is just a text file. It has these 3 lines of text. I promise to always close my files. And here we go, let's jump to the code. We've got a couple of options that it comes to when reading files. The simplest one is to just call the method. Again, this is a file object method called read. And what this is going to do is it's going to go to this file and grab all of the data in the entire file and return that as just one string. So here we actually have 3 lines. It's returning it as a single string, so it's going to be putting in the new line characters for us. And just something to note, a little trick with this, maybe a little gotcha is a better word. Once we call f.read and grab all the lines of the file, it's going to return it as a string. Then if we call this again, it's going to return nothing. It's like it goes through, reads all the lines, it's got a little pointer that keeps track of where it is. And when it gets to the end of the file, it leaves a little like marker there. And when we try and call read again, it starts at that same place, the end of the file, and sees there's no more text to read, and so returns nothing. To get around that, if I want to reread the file for some reason, what I'm going to need to do is first close the file right here, and then reopen it. And then that resets the marker that's going to go through and read the data, so I can call read again. There are other ways to move that marker around, but that's the easy way. There are also several other versions of methods we can use to read from files, and these all depend on the fact that file objects are iterators. So please remember this horribly complicated flowchart where we were learning about iteration and iterators. This was 2 lectures ago. If this is unfamiliar, or if you have any questions about this, go back, listen to that section again, stare at the slide for a while, pause the video. All right, I've added file objects up here, kind of in the middle in red. It fit well, and we've got my arrow. They're iterators. So that means we can do a number of things. We've already learned about iterators, and all of those things we can do with iterators will still work for file objects now. It means we can do things like, here, we can just call next. We can open the file, grab the first line of text by calling next on it, close the file when we're done. We can also use for loops to loop over files. So we can say, open the file, and then for L, I highly recommend not using the letter L as a variable. It looks too much like the number 1. And I didn't change it in the example. I apologize. But for line in file, or for line in F, is a great way to do that. Print L, and then close the file. So we can iterate over them with for loops. And then finally, remember that iterators are iterable, and anything that is iterable can be converted to a list. So in this case, we can do f equals open file.text to get a file object. We can say get all the lines as a list, and then just give that the file object. Convert the entire file into a list all in one step. Remember to close it when you're done. All right, and just a heads up, this slide right here might be a good one to have open while you're taking the exam. The exam is, of course, going to be open notes, open book, open internet, can't talk to anybody else. Same as the first exam, same rules. This looks like a good one to me. All right, moving into writing to files now. First up, there's going to be some subtle differences here. When we open a file, the default mode is reading. If we want to open a file for writing, then we need to use this second argument that tells Python which version of the file we want. The file object here that we can write to needs the character W. If you want to just read to a file, we can also put in the character R as a string, string R for read, but that's the default one. If you think back to the lecture where we talked about functions, we had positional parameters, we had keyword arguments, and we had default arguments. In this case, the mode is going to be have the default argument R, so you usually won't see people writing in the R. But if we want to write, we need the W. So let's walk through a little example here. So I've got my code here. This is my main.py. The first thing I see is that my file.txt already contains this text from the previous example. I promise to always close my files. So when I run this line here, red arrow indicates the line that's about to run, just like Python Tutor. When I execute that line, I open a file for write. Note that my text disappears. Opening with W immediately erases the entire contents of your file. Or if the file doesn't exist, it creates a new one for you. All right, the next thing here is we're calling the write method. The write method takes a parameter, an argument, and that's just going to be a string, whatever we want to write to the file. And it's a method again, so we need f.write. If you think back, a moment ago I was talking about read. Read didn't take any parameters, but it did have a return value, and that was the string returned when we read the entire file. Here, it does have a return value, but it's not important, so we're just going to ignore it. But the argument we're passing it is very important. This is what we need to write to the file. The next thing I want to stress here is that when we write hello and then space world, it's going to put those on the same line. We have to put in our own end lines, the \n, in order to get a new line, and then put the exclamation marks here. We get so used to using print, which automatically has that default end of line character. You can actually change it with the keyword end, if you remember back to that lecture from the beginning of the semester, and change that property. But by default, print is going to put a new line at the end of everything. Write will not do that. It's up to us to put on our own new lines. So just a heads up about that. And then, of course, it's very important to remember to close your files when we're done. All right, I didn't make a slide for this, but one of the most common questions at this point in the course in previous years is, what if I want to open a file, not erase everything that's there, and then just continue writing to the same file? If I want to add some extra data to a file, to do that, instead of just W here, I need to use the mode WA. That stands for write with append. And we've talked about append. That's how you add data to lists. Append here is the same way we're going to add data to files. So we need WA right there. And that's the only change we'll need to make. I just want to mention too, I didn't make a slide for the patterns that people frequently use when they write code. But one of the common patterns is to just prepare one gigantic string with everything we plan to write to the file, and then just write it out. 3 lines. Open, write the entire giant string, and then close it. And we can prepare a giant string. We've learned how to concatenate strings together, add more data to a string. It's a pretty common pattern. And the other versions that we'll see is to just write incrementally. We'll open the file at the beginning, we'll write to it throughout the entire usage of our program, and then we'll close it at the very end. There's a couple reasons we might choose to do this. If a computer doesn't have enough memory to store all of our variables, we may write them out to a file when we're ready. If there's a power outage or a power failure of some kind, if we've been writing to the file throughout the use of the program, we won't lose any of that data. This is the kind of thing that's used with log files also, in case there's a problem with our code and it crashes. We can see how far it made it and preserve all the data we've generated up to that point. And another reason is we may have a program that just runs for a limited time, and we want to store the results as we go, so we'll let a simulation run for as long as we have time available. Then we want the results of that we can get back, even though we're not able to just let it run forever. So next up, we're going to be moving into part 2 of this lecture, where we're going to be talking about some really important functions from the OS module. Just a small selection of things that are available, that six functions that are going to be really important for us. First up, because this is the OS module, we'll have to import this with an import statement at the top of our code. All right, so first up, the os.listdir function, and some of these are going to be in the path, submodule os.path. But the first one is just at that top level OS lister. This is essentially the same thing as doing ls from the shell. It's going to return a list of files in whatever directory we give it. All right, so here, I need to import OS before I can use it. Calling OS lister requires I give it one argument. And in this case, in this example, I'm giving it just it records a string, but my string is just the dot. Please remember back to lecture 2, way at the beginning, we talked about using the terminal and the shell. And we talked about those 3 sort of special directory symbols, one of which was the dot. In this case, this just means go to the current directory. So right now I'm in directory demo. This is main.py that's running. When I call lister on the current directory, I'm going to see that it's going to return a list, and it is a list of strings where each of those strings is the name of either one of the files or directories, and it's just going to get all of them for us. If we want to go in and get all the files in one of the subdirectories of my current directory, I can call lister and give it the name of the subdirectory, and that's going to go and look into the data directory and see here we've got 2 files, movies.csv, and the directory snapshots. I misspoke, this is the directory. And it's just going to return those as a list. If you remember, there was another one of those special path directory symbols, the dot dot. Anybody remember what that does? That's going to go back up and give us all of the contents of the directory one level higher than the one where we're currently in. So it's going to go outside of demo, up one level, and return all the files in that. And it should have the directory demo in that one. All right, next up we have the os.makedir function or method. In this case, this is very straightforward. All this is going to do is, in the current directory, it's going to make a new directory. Mkdir stands for make directory. So in this case, in this example, when I call it with test and then click, it's added a new directory to my demo folder, test. Very straightforward. And in this case, we don't care about the return value from this, so we're just going to ignore it. All right, these next three, path exists, is file, and is directory, or is dir, just ask yes, no questions, and these are going to return true or false. So for example here, os.path exists, given the name of a file as the parameter as a string. If this file exists in the current directory, or whatever path we give it, this is going to return true. If it doesn't exist, returns false. So if, for example, if we look for the file haha.txt, it is not here in the directory, this is going to be false. The next two asks about the status of a particular file. Basically, is this a file or is it a directory? Is file here, haha, doesn't even exist, it's going to return false. It's not a file. If we ask about file.txt, yes, that's a file, not a directory, so this will return true. If we call is file on data, data is a directory, so this is going to return false. If we call is dir on data, that is a directory, definitely it's going to return true. All right, I saved the most important one for last, os.path.join. This is going to take care of the problem where we're working on different operating systems. So if we're coming up with a path that's got a separator in it, in this case, we've got the / the one we use for division, data / movies. This is going to help us navigate on Mac and Linux. But on Windows, we use the /, so // And so because of this little difference, it means if we use the slashes when we come up with our own paths, this code will not be portable. We won't be able to take our code that we wrote on a Mac, give it to our friend on a Windows machine, and have it actually work for them. It's going to fail because these separators are different. So in order to to take care of this discrepancy, Python provides this os.path.join, and this takes we're just going to list all the different pieces of the path. It's going to look and see what kind of operating system are we currently working with and generate the string that we can use for the path of the file. So if this is on a Mac, it's going to go ahead, my Mac example, it's going to go ahead and create this file as a string, return it, and we can just store this in a variable and use this path when we open files. If we then take the same code and put it on a Windows machine and run it, os.path.join looks and sees, oh, it's a Windows machine, use the /. So store that as a string, use that as your file path. And here's the real problem. We've got 800 people in class. About half of you guys are on Windows machines, and half of you are on Mac machines, some Linux, not very many. So if in your project you do something like this, where you're using the string function join to take all of your directories on pieces of the path and join them together with the /, it's going to work on your home computer. No problem. You're going to run test.py. Everything will pass. But then you turn in your work. We run test.py. It creates these file paths with the wrong separator for the Linux test environment where we grade everything. And it gives you a 0 because none of the tests work. So just a heads up. Your work will fail if you do it like this, or if you write it out like this. Please use path.join. The directions are very clear. Use path.join. And yet the temptation is there to say, oh, it's in a data directory. I just write it out like I would on the shell or terminal. Don't worry if you get a 0. Just open up your submission and see read the message that says how to fix it, and then fix the problem and resubmit it. We will not fix this mistake for you, but we will let you fix it and then do a regrade. You get a full week to go back in and replace whatever you did, this line, with this line. It's not a big deal, but just be aware that that happens to a significant portion of the class. It's actually kind of a lot of work for us to let everybody know, which is why we don't fix it. We're going to require you to fix it so then we can rerun our automated tests. All right, part 3 of today's lecture, file exceptions. So what we're going to find is that working with files actually leads to a lot of things that go wrong, things that we can't really predict a lot of the time. So we're going to see a lot of exceptions, and we're just going to need to be aware that they happen and deal with them. And some common things are like missing files. If we want to write to or read from a file and we haven't created it yet, or if someone's deleted it, missing files is pretty common. And so we'll be using things to check and see if files are there, but also not necessarily perfect because other programs are running on the computer. We may check, see it's there, and then someone else will delete it. All right. Another issue that comes up is lack of permission. So if I have multiple user accounts on my computer and I create a file with one account, switch to another account, my son and I share a computer. He might be playing a game, may save his game file, and then I try and read it. I'm the administrator. I have permission to read everything, but he doesn't have permission to read anything on my side of the computer. All right. Another issue is running out of space. This will just cause things to fail. Mixing up files and directories. For example, if we call fileObject.read when it's actually a directory, that's not going to return the data from the file like we think it should. Corrupt file formats. If someone is writing a JSON file by hand and actually accidentally makes a mistake with the brackets or something, if we were to do this as a dictionary in Python, it would give us an error, it would crash. Same thing here. We're going to see that if there's a corrupt file format, someone's made a mistake putting together a JSON, it's not going to work. It's going to throw an exception or raise an exception. All right, let's just take a look at a pretty simple example, something that comes up all the time, something that at first glance looks like it should work just fine. So we'll import OS, so we have access to all of those OS functions. OS make dir. So here's the idea. Here's what I want to do. I want to create a file. I'm going to call it out.txt, and I'm just going to write the word hi to that text file, but I want it to be in this dump directory. So I look here, I see I don't have a dump directory. I'm going to create it here. OS make dir dump. Then in that directory, I'm going to open my file. Here's an example of how you use path.join. So open takes, I need to give it the path first, and then I'll need to give it a second argument to say I'm going to be writing to it. But that path, if I want it to work on Windows or Mac, I'm going to use path.join and let Python, let this OS path module deal with, do I put the / or the / between these guys? So that's how I would use that here. This looks like it should work great. Then I'm going to write hi. Perfect. That should work great too. Then I'm going to close my file. So here I run it once. First time through it creates dump for me. In dump it's going to open up out.txt. It's going to write hi. It's great. The second time through it's going to crash. When we take a look at the error message, the traceback, we're going to see that we get a file exists error. And that file, this is not a great message because dump is technically a directory, but the error message says file exists dump. And we're getting that right here on the make dir line because make dir will fail if it already exists. Now, while we're running some code like this, we don't actually really care who makes the dump directory. If it's already there, we just want to use it. If it's not there, then we need to make it. So to deal with this, anywhere we can see exceptions being generated if we run into problems, we really do need to use the try except pair of statements to check and see if anything went wrong. In this case, when we're getting this error message, file exists, that's totally fine. If it exists, that's great. We just don't need to create it. So what we're going to do instead is go and put this in a try statement, a try block, and then the except, we're just going to pass. Pass just means this block contains no code. Now, Python requires something to be tabbed over, some sort of statement here in order to know that, and in order to know that we're not doing anything, pass just means don't do anything. It's the empty statement. All right, we also only want to check for this specific error. We only want to check for the file exists error. If we just use except colon, that's going to catch absolutely every single thing that could possibly go wrong and ignore it and just hide those errors. This is the only one we want to skip. If something else goes wrong, we want to know about it. All right, we'll be working a lot more with files, and we'll be looking at some of these other things in the project coming up. So just be aware when you need to come back here and take a look at some of the examples with, in particular, os.path.join. This is the big one that a lot of students make mistakes with. If it happens, you're going to get a 0. Again, don't stress about it. Just fix the mistake and resubmit. All right, now the last part of the lecture before we get into some live coding examples, we will be talking about encodings. Tongue twister there. All right, so computers, humans, when we read files, we like strings. We need it to be text made of characters that we understand. Computers, on the other hand, are binary. They need ones and zeros. So when we take our human readable file with all of the A through Z characters, and the computer is going to store this, it needs to translate that or encode each one of those letters into ones and zeros. So here I just have an example of an encoding and something that can go wrong when we used 2 different encodings. So real quick, go ahead, take the word ukulele, use the encoding on the left to figure out exactly what Python would do with all of these numbers, with this table to encode ukulele. For example, if I have the letter U, I'm going to find U in the chart over here, and Python is going to write to the file 10101. All right, go ahead and do this for the entire word ukulele, figure out the entire code, and then come back. If this is the thing I use to encode, and then I move to another system or another program is going to read it in, and it uses a different encoding, use this code to translate it back. So go ahead, pause the video, give this a try. It's kind of a fun exercise. It doesn't take that long to do. And then I'll be right back. All right, so I'm back. Hopefully this example drives home the very important point that once we've encoded a file with a certain kind of encoding, we need to use the same encoding to read back or we get problems. So check this out. If we were to do this, up here I've got the word ukulele encoded, and when I bring it back, so the U here was 10101. When I find that in the chart over here, 10101 is actually the letter L. So I'm going to get an L here. And then K, let's see, K was encoded as 01011. And let's see, there it is, 01011. That's going to translate to O. So in the end, LOL, because the U is still the same. When I find the L over here, 11111, that doesn't even appear in this chart. So what do we decode that as? Who knows? And this is another case here with the E. E is 5 zeros. Over here, E is again 5 zeros. So this one actually works. We get some of the letters that, so we're going to see one of 3 things here. The E is a great example of the encoding actually working. It's a lot of them are actually quite similar. So we'll see that we get some letters that are not changed. This is another example of the second thing that can go wrong. We get letters that are switched for other letters. So we start misspelling things. And the third disastrous thing that can happen is we get something that's encoded that is not in the decoding thing at all. The decoding, encoding. Encoding 2 doesn't have anything that matches the letter L, so we don't really know what to do, and it's going to crash on us. All right, on Mac and Linux, the default encoding is almost certainly going to be something called UTF-8. And in fact, our open method, the one that can be called from anywhere that creates a file object, can take a keyword parameter called encoding, where we can tell it what kind of encoding we wish to use. And the default on Mac and Linux is UTF-8. So when we write a word out, and this one actually happens to include a special character, when we go back, save this as a text file, send it over to the Windows computer, and open this back up, Windows generally is tending toward using UTF-8 also as the most common version, but they actually have many different encodings that they use. So if we happen to read this one back in using the encoding CP1252, what we're going to see is it translates this word into this one with a weird messed up character here, the plus or minus symbol, and it gets the B, A, and O correctly. But the special character, it totally mangles. All right, so the takeaway message here is that if you start to see weird characters printed out by your program, it's a good time to go back and just check and see if this encoding problem could be the potential source of the weird characters. All right, time for some live coding demos. The files you guys need, if you want to follow along and do this, are available on the code directory. Let me jump over there and talk a little bit about them. All right, so here we are, week 10, files and directories. I see Mina has already beat me. She always does. And I'm actually recording. It's 12:49 p.m. This is the afternoon. That's not even like the middle of the night when I usually get to this, or if I get up early. All right, enough of that. Under the code directory, we've got a number of files available. Okay, this gen.py file just creates two files, short.txt and a nums.txt. This is going to be just a file that contains a lot of numbers. We're going to use that with the demo code here. We're going to read in the list of numbers and add them up. These other files, point file finder, are for the other demos that you guys can work through on your own. And test file finder is just filled with a bunch of files that file finder, that's for this file finder example. So go ahead and download those if you wish. Now, in order to follow along with the example I'm about to do, you'll need to run gen.py. And I've already done that, but let me just jump over and demonstrate what you need to do. Okay, so I pulled up PowerShell here on a Windows machine. Use terminal if you're on a Mac. I'm going to type ls, and this is going to tell me the files I've got here in this directory. Gen.py is just a Python program that's going to create short.txt and nums.txt. All right, nums.txt is an absolutely enormous file. It does take a while to generate. Let's see, we've got 1, 2, 3, 4, 5, 6. So that's 195 megabytes. So it's a large file. Just be patient. It'll take a few minutes. All right, so next thing I want to do is I'm going to jump up and read this. Oh, this is the demo lecture 26. This is actually lecture 25, I think. But this is the Python notebook that has all of the complete solutions to everything. So I'm going to go create a new notebook and then walk through reading this file and adding up all of the numbers. So let me go ahead and open Jupyter Notebook. All right, so I've got Jupyter Notebook open, but then I wanted to show you guys what's really in nums.txt. And I looked around for a little while for a way to like quickly open it up. It's a big file and it took a while, but Notepad handled it with no problem. But here's the idea. It just contains a bunch of random numbers between 0 and 100. It actually contains 50 million numbers. Oh, what is this? All right, let me try it again. So I did not predict that trying to open nums.txt in this in Jupyter Notebook would cause it to crash like that. I did try it, and then it took forever, and I just moved on to open it with Notepad. All right, so here's what we're going to do. We're going to open up a new Python 3 notebook, and we're going to write a program to just read in those numbers and add them up. All right, so first thing, I'm going to need to use that OS module. So we're going to import it first. Import OS, piece of cake. We'll run that cell. And I'm going to put all my imports up at the very top in that first cell. Next thing, let's just take a look at some of these functions and explore what they do. os.listdir, I'm going to give it the current directory like that and just see what's here. All right, so I've got the completed version, post-lecture. This is what you guys can go download and see what I'm about to create. File finder was for that other demo. I'll come back to that. Gen.py was the one that we'll use to create nums.txt right here. Points is for the other demo. Short is just a short list of numbers we can use to test things more quickly. And untitled, that's this one right here. Let's give this a new name. Main. All right, perfect. Actually, let's call it, yeah, that's fine. All right, next thing I want to do is go ahead and create a function that's going to add together all those numbers. So I'm going to call this add nums. I'm not going to give it any parameters. And first up, let's just go ahead, open the file. We'll print something out and make sure that it's really opening. So we're going to create a file object with open, and it needs a string, nums.txt. Okay, so the file's open. When we're all done, f.close. When I write code, I like to put my open and close. These are the important parts of the protocol. I write them both at the same time and then move the cursor back up and put in the code in the middle that I want. All right, so let's just print off something. We'll do we'll do next f. So next is a built-in function. It's not a method for f. Now this is going to work with anything that's an iterator. I'm going to go ahead and just call this add nums and verify that we're getting a number. Do I still have Notepad open? Oh, I closed it. I was going to just check and make sure the first number is 98. Let me go ahead and open that back up. All right, yes indeed, the first number is in fact 98. If you guys are running this at home, you're likely going to find that you're getting something different. Let's go take a look at that gen.py real quick. So what we're seeing here is that it's going to create short.txt and nums.txt. All right, nums.txt is going to generate 50 million random numbers, and we're just calling a function random int. So because of that, the numbers that you get will probably not be the same as the numbers I'm getting. Just a heads up that it might not be 98. Okay, so at this point, we're opening the file, we printed out a number, and then we're closing the file. So what I really want to do is go through the entire file and add up all the numbers. So for my first attempt, I'm going to take advantage of the fact that this is iterable, f is iterable, and turn this into a list. So let's just call this nums equals list f. So this is how I create a list from an iterable object. And once I get that, I can just do, here we can just return sum of nums, just like that. And then let's go ahead and run this. All right, I'm going to pause the recording. Oh, I don't need to. Let's see here. We've got some problems. First up, memory error. Didn't expect that one. Let's see what happened. This is when I tried to turn my list into nums. All right, so I suspect that this is a limitation of me trying to create a list with 50 million items in Jupyter Notebook. I don't really think this should be a problem. I'm going to jump over and copy this into idle and just try running this exact code again. 1 second. Looks like I need to... I didn't quite get it all. Import OS. Now that should be everything. All right, let me save this and we'll run it real quick. So there, print out 98. It's working, and I'm just waiting for it to read all of those numbers. All right, and now this is the error I was really expecting. So unsupported operand types for plus, int, and string. So please remember that when I'm reading something in, it's giving me a list of strings. Everything here is going to be a string. So let's take a look at this right here. Next, this was printing out a string. This is creating a list of strings. In fact, if I were to just print, let's see, let's do a quick slice of the string. So nums, we'll just grab the first 5 elements, print those out. All right, save, run. Wow, this takes a really long time before I found out that there was a problem. I wonder if there's a better way to do that. Yeah, check this out. Okay, so we got a bunch of strings. 83 with a new line, 63 with a new line. No wonder we can't add these together. Plus equals doesn't work like that. Oh, in which plus equals is going to be what's going on inside the sum here. Essentially what we're doing is we're getting a total equals 0, and then instead of this, let's do it this way, for x in nums, total plus equals x. So this is what's going on the inside of sum. It just does that for us in 3 letters instead of 2 lines, or 3 lines. This is actually a really easy fix. I just put int right here, and now when I run it, it's going to work great. So save, run, but it's still taking a really long time. All right, I've got a decent computer. So there, printed out the string. It's going to turn all these into integers now, add them together slowly. Oh, I forgot to print it out. Ah, curses. All right, there we go. I fixed it. Now, this is taking a long time. I don't want to make you guys wait. I'm going to go ahead and upgrade this and come up with a slightly better version, a version that would have told us we had a problem right away. So this is a pretty simple upgrade. Instead of turning everything into a list and doing this all at once, I'm going to just take advantage of the fact that file objects are iterable. And that means I can just go straight here and put the f into this loop right here. So now this is going to use the next function. For is going to call it for us, and it's going to go and grab one number at a time. And if I were to accidentally leave this out, I'll put it back in a second, it's going to give me that error message right away. So save this, run it, and instantly I get the error message. It tells me right away that I've made a mistake and I can't use plus equals on total, which is an int, and the first number, string 98 with a new line character. So I can know instantly that I've made a mistake. I can go back here and I can put an int right there like that. And now I can run this. And this should again take quite a while. Maybe not as long because I'm not turning into a list first. I'm just using the data directly. And then it's going to print out the total in... that's not good. 1 second, what did I do wrong? Alright, that was dumb. Alright, so I've computed the total right there, and then I took out my return statement. So, return total. Alright, I'm really curious. I want to know how much this actually adds up to. I'm going to run it one more time. Final time, guys. Answer in 5, 4, 3, 2, 1. Alright, I only got the timing right because of the magic of video editing. I was totally wrong. It took a few seconds, but we see a huge number there. It is 50 million numbers between 0 and 100, so we should be getting expectation value about 50 times 50 million, which is 250 million, so that's looking like it's about right. Alright, before I sign off for today, we have two other practice demonstrations. Most of our PowerPoint slides have extra practice problems at the end, things you guys can go look at. We've got some files in the direct code directory that you can use, things just for extra practice. And I highly encourage you guys to go through these just as a quick review. We've got an exam on Wednesday. These are things that are going to be good to know. Alright, so this first one, the code in the code directory is actually the complete answer, so you can check your work when you're done. And you can experiment with it and try it out to just see what it should really look like. Your goal is to write a program where we're going to be calling point.py and giving it the name of the player who scored a point. And then we're going to give that player 1 point. We're going to keep track of the player's total score in a JSON file, and then as we go through, we'll run this a couple of times. We'll give Bob a point, we'll give Alice a point. So check this out. So Python point.py Alice gives Alice 1 point. It's going to print out the total for all the people playing the game. So if we give Alice a second point, and then maybe Bob scores, and then Alice again, and then Carl. Alright, there we go. And what we see when we do ls is that it's creating this point.json file. I highly recommend you guys go through it, try this out, see if you can write this on your own. It's great practice, great review. The other program here, File Finder, this is actually very similar to something we'll be doing in an upcoming project. But File Finder is just going to search directories, and again recursively. So you can use list directory or lister to get a list of everything in a directory. You can go through that list, and we're going to search for a particular file. If we find that file, we just print it out. So we'll open the file, we'll print everything to the screen, and then we'll close the file. If it's not in the current directory, then we'll go through all of the directories there, and one at a time we'll call File Finder on those directories. So it goes into those directories, takes a look at them, see if it's there, and then we'll print those out. Alright, let me just demo this real quick. Here we go. So ls, it's right here, filefinder.py. It takes two arguments. 1 second, filefinder.py. The first one is the name of the file we're searching for. So let's real quick search for short and we'll print it out. And the directory we're going to give it is the current directory. It happens to be right here. We'll begin our search right there. So I'm going to push enter. It finds it right away and prints out the contents of the file. Now I've also got this test file finder in here, and you can use that to explore your program. So I'm just going to move short into test file finder. So it's now one level deep in this. You guys can open that up on your own and explore. So now if I list, I see that short is no longer present. And so now I'm going to do the Python file finder.py and look for short.txt. And we can see it still finds it, even though it's no longer in the current directory. It's searching all of these subdirectories. So this is another great practice exercise, great for the upcoming project. And if you can get through this, it'll be good practice for the upcoming exam. All right, so that's going to do it for me. Good luck on the exam. If you guys have any questions, please come to my Q&A session immediately after I'm done live streaming the lecture. A live stream will begin at 8 a.m. And then on Wednesday, there will be no lecture, but I'll be available during regular class time from 8:50 until people are done asking questions. Go ahead. My recommendation is to go look at those practice tests and see if you run into any questions about the practice exams and bring those with you to the Q&A sessions. All right. Have a great day, everyone.